long continued works by the wind through the mechanism of aberration or sandblasting and deflation process produces characteristic landforms in the desert areas. Wind erosion is largely controlled and determined by the wind velocity, amount of sand, composition of the rock, vegetation and climatic factors like rainfall and temperature. In this lesson, we are going to study various landforms produced by the action of winds. In the desert areas, besides the wind, the role of rainwater is also there in carving various fluvial landforms. The main objectives of this lesson are: 1. To know what are the Aeolian erosional landforms and how they are formed. 2. To understand the role of water in the formation of fluvial desert landforms. Aeolian erosional landforms. Long continued erosional works through the mechanism of aberration and sandblasting and deflation processes produces some characteristic landforms in the desert areas. Wind erosion in the arid and semi-arid regions is mostly controlled and determined by wind velocity, amount of sand and nature of the rock. Major Aeolian erosional landforms include mushroom rocks, zugane, yardungs, demoiselle, deflation basin or blowouts, desert pavements, inselbergs, ventifacts, windows and bridges, pediplane and hamada. Mushroom rocks. In the desert areas, when the wind blows, the heavier sand particles roll down the land and lighter particles are lifted and blow above the ground level. When the rock in the path of the wind is subjected to sand blasting, the lower portion of the rock is eroded more than the upper part of the rock. The rock resembles the form of a mushroom. The rock assumes the broad upper part and narrow base resembling the mushroom. Such rocks are also called as pedestal rock. These mushroom shaped pedestal rocks are formed when the erosive work of the wind undertakes rigorous undercutting of the rock, while the upper part of the rock is least affected by the aberration. These pedestal rocks are called as Gara in Sahara and Pilsfelsen in Germany. Zugane. Zugane are formed where rocks of varying resistance are horizontally bedded. The rate of erosion is different in areas which are parallel layers of hard and soft rocks. The lower soft portion of the rocks is eroded fast and becomes narrow. The lower portion of the rock is eroded fast, but the upper portion of the hard rock looks like tables on the narrow soft rocks. When the soft base of the tabular mass is eroded, the tabular mass falls down on the ground, which is called as zugane. Yardungs are formed when alternate bands of hard and soft rock are vertical in nature. The layers of soft rocks are mostly fine-grained, is aberrated and eroded material is blown away by deflation process. The resultant area resembles ridge and furrow landscape. The yardungs are thus steep-sided undercut rock ridges separated from one another by long grooves and furrows. The rocks resemble ribs with steep slopes. The most characteristic feature of the yardungs is their parallelism. That is, their formations are parallel to one another. The yardangs are usually 8 meters high. They are generally formed in the areas which are characterized by directional steady winds. They range in size from meters to kilometers. The yardangs are common feature in the Central Asian deserts and Atacama Desert. The biggest yardang in the world is in Lut Desert in Iran. Demoiselles. They are also called as earth pillars. Demoiselles are formed in areas where a hard surface rock protects a softer underlying rock. The cap of the rock protects the underlying soft rock while the surrounding areas are lowered. Demoiselles represent rock pillars having relatively resistant rocks at the top and soft rocks below. These features are formed due to differential erosion of hard and soft rocks. The demoiselles are maintained so long as their resistant cap rocks are seated at the top of the pillars. Deflection basins or blowouts. Depression basins or hollows are formed in the desert due to the removal of the sand through the process of deflection. They are also called as blowouts. The depth of the depression or hollows is determined by the groundwater table. Depression hollows are most commonly found in the sandy deserts, and many of the oases are formed in this manner. The patches of greenery will be associated with the oasis. A settlement in the desert areas are often developed around such hollows. The size of this depression varies from smaller one like Buffalo Valleys in American desert plains to a very large depression like Katara Depression in the western Egyptian desert. Desert pavements. Deflection is the selective process, removing only the smaller rock particles and sand. The large size materials are thus left behind by the wind. The ground in the areas of strong winds is thus left covered with boulders and pebbles. Deposits such as gravels and pebbles left behind by the wind are called as lag deposits. Such deflation surfaces are often described as desert pavements. Desert pavements are formed when the fine pebbles go on escaping the deflation armor and even after its formation. The stone pieces gets much compacted as if they are hammered together. The compact layer gives rise an appearance of a pavement. Depending on the size and the amount of particles, such areas are given different names in different regions. The term reg is applied to the areas of lag gravels in Algerian Sahara. Similarly, areas covered largely with pebbles in Libya and UAE are called as serir. Surface covered by large rocky fragments in Sahara is called as hamada. When the fine material is removed due to the deflation process, leaving behind a mosaic of pebbles called as desert pavement. There are many stones in the desert pavements which are black and brown in color polish. It is due to the presence of iron manganese oxide is known as desert varnish. Inselbergs. Inselbergs are residual hills in a peneplain. They are similar to monadnocks found in the peneplain. It is also called as bone heart. Appearance of inselbergs indicates the last stage in the cycle of erosion in the arid areas. Inselbergs are steep-sided hills rising abruptly from the plane of low relief. Inselberg is a German term meaning island mountain. Inselberg is considered as the typical landform of the old stage of arid cycle of erosion. Ventifacts. Ventifacts are triangular pyramidal shaped stones which appeared at the base of the rock cliff or the hill. The rocks having 3 aberrated facets or edges are called as tricanter or ventifacts, while the stones with 2 aberrated faces are called as zwicanter, and one side is faceted, they are called as icanter. The stones are subjected to sand blasting and develops edges or facets. Due to the aberration, sometimes their shape may resemble tetrahedron. Due to wind aberration, they may be faceted on one or more sides. Windows and bridges. The continuous aberration of the rock by a powerful wind results into the formation of holes in the rock which are gradually widened. Such holes are called as windows. These holes are further widened and enlarged through the process of aberration and deflation in such a way that an arch-like feature is formed, which are called as bridges. For example, Rainbow Bridge in southern Utah in USA. Peneplain. Peneplain is a surface of low relief with isolated hills called as inselbergs. They are usually made up of resistant rocks. Peneplain is more or less a plain area which is considered as the ultimate or final stage in the cycle of erosion. Hamada. In desert areas, due to the deflation process, most of the sand is blown away due to the wind, due to which the floor of the hard rock is exposed. The sandy deserts, due to the removal of the sand, is now converted into rocky desert surface called as hamada. Hamada is common in Sahara Desert. Fluvial desert landforms. Very few parts of the world's desert are absolutely rainless. Rainfall, although very low, sometimes will be in the form of convectional rainfall with cloud burst. Though rain is scarce in the deserts, it comes down torrentially in short period of time. The streams in the desert areas are mostly ephemeral or short-lived, but they become active for a brief period due to torrential rainfall from the cloudburst leading to sheet floods. Stream channels in the desert areas not well defined and flow for a brief time after rains. In fact, many features of the desert landscape owe their formation to running water as sheet flood. The drainage pattern of the desert areas is known as internal drainage pattern. The desert landscape is characterized by typical features which includes fluvial landforms such as 1. Desert canyon, 2. rock fans, 3. desert pediments, 4. bajada, 5. playa lakes, 6. desert washes or wadis, and 7. balsams. Desert canyons. Mountain terrain in desert areas gives rise to erosional landforms such as desert canyon. It is a narrow gorge created by the river in the desert mountainous areas. The water received from the cloud burst in the arid lands carries loose sediments and effect a deep downward cutting. Many depressions are formed along the mountains, and these depressions in course of time take a form of a canyon. Rock fans. During cloudburst or sporadic rains, water moves down through these gorges with heavy load of sediments. As soon as the river reaches the foothill zone, the river dumps the sediment load due to the sudden decrease in the channel gradient in the foothill zone in the process of dumping. The coarser material of the load is deposited first and finer material moves further down. The material takes a fan shape with a narrow apex and broad base. Such fan shaped deposits are called as rock fans. They are later filled with alluvium and are known as alluvial fans. Desert pediments. In the desert region, broad, gently sloping or relatively flat surface develops as at the base of the receding mountain fronts. The slope of the higher portion of the mountain is relatively steep, but the lower portion records a sudden change in the slope, which is very gentle. The line of change of slope is almost straight at the base of the mountain, that is the Piedmont area. The whole slope from the mountain to the playas is called as Piedmont zone. The Piedmont areas has three parts: pediment, two bajada and three playa. Pediment zone. The upper part which cuts into the side of the mountain is known as pediments. Pediments are situated between the mountain front and the bajada in the intermountain basins. They are broad, extensive and gently sloping areas of rock cut surfaces. The term pediment was first used by Gilbert in 1882 for the surfaces of alluvial fans which encircles the mountains in the desert areas. Pediments are slopes usually covered with veneer of alluvium in transit from higher to lower levels. Landscape evolution in the desert is primarily concerned with the formation of extension of pediments. Gently inclined rocky floors close to the mountains at the foot with or without a thin cover of debris are called as pediments. Such rocky floors are formed due to the erosion of the mountain front through a combination of lateral erosion by streams and sheet flooding. The pediment is generally concave in profile. Bajada is the gently sloping depositional plain between pediments and playa lakes. Bajada or Bahada zone, which is characterized by fan-shaped deposits which extends up to the sides of the mountain. A sudden cloud burst gives heavy rainfall. The sediments from the eroded slopes are deposited at the base of the hill or rock cliff, leading to the formation of alluvial fans. These fans expand laterally and coalesce into one another, extending from the Piedmont slope area to form the bajada. Bajada is formed due to the coalescence of several alluvial fans. The slope of bajada zone is very less. The slope in the upper part of the bajada is slightly higher and it is very insignificant in the lowermost portion touching the playa lake. Bajada is also called as bahada or peripediment. Playas. A part of the rainwater received at the time of cloud burst percolates in the porous areas composed of pebbles, gravel and seeps underground. The part of the seeping water rises in the lower portion of the fans. A lake is formed at the lower slopes of the bajada whenever a depression exists. Such lakes are called as playa lakes. They are known as sabachas in Sahara, kiwire in Iran, and takir in Transcaucasia, shorts in North Africa, and playas in North America. These lakes are mostly temporary in nature. Playa lakes may last for few days, few weeks, or even longer before they are completely dried up by evaporation. Due to high temperature, water is evaporated and these lakes become dry, leaving behind layers of salt. Such dry lake with hard surface layer composed of salt is called as salinas, or salt covered playa lake beds are called as salinas. Desert washes or wadis. The stream bed or channel of the stream in the desert areas is usually dry except in rainy season. These streams are filled with loose material such as gravel, sand, silt that is collected from the mountain slopes, transported and deposited by the running water. Such streams course due to the cloud burst deeply erodes the stream bed and makes valley deep and broad. Such stream courses are called as desert washes in USA and wadis in Sahara and northern Africa. Bolsons. The intermountain basins in the arid and semi-arid areas are generally called as bolsons. Bolsons are more or less rimmed by mountains. In desert, the mountainous areas are separated by basins called as bolsons. It is an extensive flat alluvium colored floored basin or depression into which drainage from the surrounding mountainous areas get collected. Numerous ephemeral streams, after originating from the surrounding mountain fronts, drain into the bolsons. The basin is characterized by the centripetal drainage which leads to the formation of lakes. Conclusion. Aeolian erosional landforms are produced by the action of wind in the desert areas. Wind in itself cannot do much of the erosion, but when it picks up the sand particles by the process of deflation, these sand particles becomes erosive tools. Erosion by the wind is undertaken by the process of aberration or sand blasting and attrition. Some of the major erosional features produced by the action of wind includes mushroom rock, yardungs, desert pavements, deflation hollows, inselbergs, etc. Sometimes the streams in the desert areas, which are mostly inconspicuous, becomes active due to heavy short duration rainfall received from the cloud burst. The resultant fluvial desert landforms is characterized by the features such as desert canyons, desert pediments, vajadas, playas, washes, wadis and bolsons. In the next session, we will try to know more about the formation of desert.